Good afternoon. I'm Kim Newton with the Public Affairs Office of NASA's Marshall Space Flight Center. Welcome to our panel discussion recognizing the 10th anniversary of the full-time habitation and crew operation of the International Space Station. The International Space Station is one of the greatest engineering and science achievements and international partnerships in human history. Marshall Center is proud to have played a significant role in the development and integration of the International Space Station. Welcome today to our panel discussion, and we have our combined panel here has over 100 years of collective experience in the International Space Station. Let's start our discussion with the introduction of our panelists. First, I'd like to introduce LaBrice Woodard, who has served in many management and leadership capabilities supporting the coordination and operation of science operations on board the space station. Next, I'd like to introduce Bob Bagdigian, who has served some 23 years experience with the development of the vital life support and environmental control systems on board the space station. Our next panel member is Annette Sled. Annette has some 27 years of experience with the development of space station, including leading the teams which built the express racks for the modules of station. Express racks are the structures which house several science experiments and supporting facilities on board station. Next, I'd like to introduce Richard Grugel. Richard is a material scientist here at Marshall and has flown 2 science experiments on the International Space Station. Last, I'd like to introduce Sean Reagan. Sean represents a team of engineers and international partners who built and delivered 3 multi-purpose logistic modules, the moving vans of the space station program, which have delivered thousands of pounds of cargo and science experiments and facilities to the station. Sean will also address Marshall's role in the development of 2 space station nodes. Let's begin with LaBrice Woodard. LaBrice?
Well, good afternoon, Kim.
Good afternoon.
And I'll talk a little bit about the group of folks that I represent here today. I work with the team that performs the 24/7 real-time support for the experiment operations that are aboard the International Space Station. And our team is encompassed with engineers and technicians that have been working together, culminating the idea of doing science on board station since the early 90s. Excuse me, the mid to late 90s, in fact, really. We pulled together all the concepts that we needed in order to get the ideas for how we support the science experiments on board in the very late 90s, and in fact we culminated all of that planning to be able to be prepared to support the very first expedition of around-the-clock science operations in 2001. That was when we began Expedition 2 with the space station crew. And that was started with Flight 5A.1. It seems like so long ago now. Mm-hmm. But the team, we came together and had all the disciplines represented that represented all the training, all the planning, all the scheduling, and the procedure development for all of the experiments that came together at that time and have subsequently been coming together for each of the expeditions. So we are very, very proud to be able to represent the research community. The idea is that when we get to execution, we are making their dreams come true. Yeah. And so we are very proud of that.
That's great.
So
thank you.
Bob, tell us a little bit about what you do.
Okay, LaBrice. My job and the people I work with was not so much geared towards the science part of Space Station, but more enabling the crew, giving the crew everything they need to be able to occupy and live comfortably and do the science work that the space station is all about. A lot of things go into making or keeping people alive, and a lot of it we tend to take for granted. In any type of spacecraft, whether it's a space shuttle or space station, the part of that spacecraft that's responsible for keeping the crew alive, we call that environmental control and life support. And as the name implies, it keeps the environment comfortable, it keeps it safe, and most importantly, keeps the people alive. There's a lot of parts of an environmental control and life support system. What Marshall worked on even before station became permanently manned is we worked on technologies that allowed us to more efficiently keep those astronauts alive and well while they're up in orbit. A lot of things we take for granted. People need oxygen to breathe, they need water to consume, and while they're doing that, they're generating a lot of wastes. What we've developed here at Marshall for the space station were systems that allow us to take those wastes and recycle them back into reusable water and oxygen. And that helps the space station by making it less dependent on always having to have a space shuttle or some type of resupply vehicle supplying oxygen and water from the ground. So it was a very long and challenging project. We were very excited to be a part of that. It was exciting as engineers to be working on technologies that hadn't been used before, but it was also exciting to be able to allow the space station to finally be able to live up to its potential and do all that science that Labrise helps organize. So it's been a very cool ride, and I was very privileged to have a chance to be part of it.
It's really nice.
Annette?
I manage the payload facilities that Marshall is responsible for. As Kim mentioned, my longtime history is with the Express Racks, which came out of the idea to outfit a space station rack, which is a refrigerator-sized container that most all the space station hardware goes in and attaches to the modules. But to outfit it to accommodate simpler, smaller payloads or experiments for various types of research. So we have built 8 flight racks, 7 of which are now on orbit. The last flight rack is planned to launch in November on the ULF-5 mission. Those have accommodated all types of experiments, crystal growth, material science, life science, both plant growth, mice experiments to determine the effects of microgravity on live specimens, and together have operated almost 200,000 hours among the 7 racks currently on board the station in all 3 lab modules provided by the U.S., the Europeans, and the Japanese. And it's been very rewarding to see how the people have worked together to come to make this happen, and it's been a contribution of just a lot of people working together and providing the resources for the scientists to do their experiments on station. And then we also have the Wenda Observational Research Facility, which was launched earlier this year, and will facilitate earth science using the optical quality Wenda in the U.S. lab. There's some specific payloads. One is EarthCam, which is operating in it to support middle school educational aspects, and then the other experiment planned for it is an agricultural experiment to look at the soil conditions, irrigation, that sort of thing to help farmers. We hope to expand this to do more with earth science research, disaster relief, and that sort of thing by looking at the Earth from space. Also in my office is the microgravity science glove box, and this provides an enclosed environment for experimentation, using gloves to manipulate the hardware, but providing the enclosure to protect the crew from any loose particles, contaminants, that sort of thing. And they have accommodated approximately 20 experiments since 2002 when it was launched, and provided both by the Europeans and by U.S. researchers, and has been termed the backbone of station research. In addition, we have the Materials Science Research Rack in my office, and it provides for materials research, both in metals, alloys, and has processed 12 samples to date from aluminum and copper alloys. Will allow the samples to be heated up to 1,000 degrees Celsius and then re-solidified in space without the effects of gravity to determine higher quality materials for use on orbit. Can also support ceramics and semiconductor research as well. With that, Richard, tell us more about the science.
Oh, thank you. My involvement with the space station goes back a while when I was the project scientist for 3 material science investigations. I was then fortunate enough to have 2 of my own. The first one was the PFMI, or Pore Formation and Mobility Investigation, where we looked at an organic material and looked at gravity-independent effects on solidification and melting behavior. And that was conducted in the material science glove box. And the second experiment was the ISSI, or in-space soldering investigation, where we did a systematic series of experiments with materials available on the space station, where we looked at solidification and soldering phenomena. And then right now, because we have such good facilities here at Marshall, I'm evaluating the first first American PI sample that came out of the MSRR rack, and we're doing that in our laboratory here and finding some interesting results. I think that's what I'm up to now. So.
Okay. In my office, we have the project management responsibility for the multi-purpose logistics modules. We have 3 modules that were built by the Italian Space Agency for us under a barter agreement with NASA. They built those modules and delivered them, one module in 1998, one in 1999, and the third one in 2001. The 3 modules named by the Italian Space Agency, Leonardo, Raffaello, and Donatello, named for famous Italian artists and engineers. As you've heard Bob and Annette talk about the racks on the science racks and the ECLS racks, you got to have a way to get them up there, and that's what the logistics module does for us. It provides an environment where we can put up to 16 racks in the module and carry them up. The module goes in the payload bay of the shuttle, goes up, comes out of the payload bay, is docked to the space station for the duration of the shuttle mission. The crew will go in, unload the supplies that we've taken up to space station, and then repack it for those items that need to come back, the experiments that are completed and need to come back, and those types of things. So then it goes, once the crew is completed, they'll close the hatch, put it back in the payload bay, and bring it back home for each flight. So that's kind of a typical flight for each of our modules. One thing that we're doing differently for the upcoming flight that we have, which is the November flight that Annette mentioned in ULF 5, we're leaving one module up there permanently. Basically, it's going to become the closet for space station. Obviously, in any house you need a garage or an attic or somewhere to store all of your stuff. So that's what MPLM, as we call it, is going to become. To do that, we had to do some modifications to the module. Since it was built for a typical 2-week space shuttle mission, the debris panels around the outside of it were not quite as thick, so that we could save on weight. Obviously, so we have more weight to take up for the items that the experiments and the racks that were needed for the rest of space station. So we had to go back and reinforce those debris panels for this flight coming up. We went back to the Italian Space Agency, to their contractors. They came back. A lot of the original designers were back helping us with this modification. Brought the new hardware down to Kennedy Space Center down in Florida, and spent basically the whole summer down there helping us retrofit the module with the updated debris shields and everything. One of the other modifications that we had to make was for maintenance of the hardware inside the module. This module was built with the idea that it would always be serviced on the ground. So we did not put in a lot of the things that the other modules on space station have for crew getting access to the hardware and the boxes and everything if they had to do maintenance on orbit. So we had to go back and do some retrofitting there, rerouting of some electrical cable harnesses and that type of thing. So we've done a lot of work over the past summer to get ready for this coming flight. so that we can leave this thing up there permanently. One other thing to mention about the multi-purpose logistics modules is we've had 10 flights to date. Our first flight was, Labrice, you mentioned 5A.1 earlier. Our first flight was also on 5A.1 back in 2001. It was the first flight in MPLM. So we've flown 10 times since then, always up and back on the shuttle. So this will be a unique experience for us this November when we go up and leave the module up there. So it'll be nice to see our hardware stay up there on orbit this time and be able to see it whenever the shuttle backs away and see some pictures of it. One other thing that our office has done has helped with the development of the Node 2 and Node 3. Those are basically the connecting blocks for station. Harmony and Tranquility are the names given to those two modules. Those were built by the European Space Agency, again, under agreement with NASA, and our office has had a lot of interaction with the European Space Agency as well as Johnson, who has the project office out there for those modules. So both of those modules are already on orbit and flying on station. In fact, those two locations, those two nodes are where the MPLMs and the PMM have docked on the past 10 missions and on the upcoming mission as well.
Cool. Thanks, Sean. That sounds interesting, and I can't wait to see the PMM attached permanently as well. That'll be nice to see. And thank the rest of the panel members for that interesting information about what Marshall does and has done over the past 10 years with the International Space Station, since we are celebrating this 10th anniversary. And I'd like to start out by asking some questions, and just wanted to ask Bob, you know, looking back at the past 10 years, Bob, what do you think is the most interesting accomplishment that happened on the International Space Station while you've been working on it?
Well, it's hard to decide exactly where to start. One of the things I've been fascinated with is historically, space missions are very well-defined, very highly planned out. You could call it scripted. You know, everything, you know just about what's going to happen literally every minute of that mission, and what the vehicle is going to look like, how it's going to be operated. And unless you have a problem or something, which have happened, you have a pretty good idea of what's going to happen in that mission, what that vehicle is going to look like. But Space Station, back 10 years ago, or even before that, when we were in the development stage, I think if you had asked all of us what we expected the space station to be looking like today and how it would be used, I think you would probably get 5, maybe 6 or 7 different opinions. So the thing that's really struck me is how over this past 10 years the space station has evolved, it's adapted, the vehicle itself has changed from what original thoughts have been, the way we're operating it has changed. It's to me it's actually quite remarkable, and then to be able to do that in such an international collaborative environment where a lot of times we tend to throw the word team around a lot, but I think actually in the space station case, I think that term is very well deserved. It definitely is a international team effort. I don't think it ever could have been possible for this vehicle to evolve to the state it's in today, and to continue to have so much promise for the future. It's the 10 years is just the start of it. There's certainly more to come from this vehicle, and I'm sure the science guys are happy to hear that too.
Yeah.
One thing I'd like to piggyback on, Bob, that you mentioned was the intense coordination, the planning, and the scheduling, and the such. Imagine now, since all of our partners are on board, almost all the hardware has arrived. We've got a few things that are still ahead of us, but with our European Space Agency, with our European partners coming on, and our Japanese partners, it has been such an amazing choreographed work of art to see how all the science between all the flight control teams associated with all the partners actually pull off all the science that gets accomplished. One would think that, and one of the goals of Space Station is that we are in a laboratory environment where you can, roll up your sleeves and you can walk in and do a unique thing on every day. And amazingly enough, One day we'll probably be that relaxed. Right now we're still in that early phase. Now that all of our partners have been there since 2008 timeframe, we are learning how to do that choreography amongst all 15 partners now. And it is you know, the show When a Plan Comes Together, it is an amazing thing. There is so much science that is getting accomplished now, and it is truly a work of art to see all the plans and the schedules that all of the partners pull together on a daily basis in order to get science like Richard has spoken of and Annette has talked about, that is actually getting executed in the racks in all the partner modules as well.
That's an interesting point that you talk about the international partners, and I was going to ask some of the rest of the team too. What was it like working with all these international partners? Maybe Annette, I don't know if you can elaborate on that.
Well, it's been a good overall experience, partly because we've all had the common goal of building the hardware and doing the research together for the good of the entire team. Certainly face-to-face meetings and interactions are necessary to build relationships, to build up the trust among the teams, and to then continue to work issues through telecons and emails and that sort of thing. But material science research rack houses an international furnace provided by the Europeans. The microgravity science glove box was built by the Europeans under Marshall management and continues to be formally sustained by the Europeans, but yet managed by Marshall. So it's been a true collaborative effort with the international partners.
And I think there's been a kind of two sides of that as well. You know, Labrice has seen the operations side, which he talked about, as Annette said, and on the logistics modules as well. Excuse me. We had the development and hardware build part of it, where you were interacting back and forth more on a technical level of, you know, here's the requirements of what we want to build, and then they would come back with these design options, and we would have to evaluate that versus what our requirements were at the time. And a lot of back and forth with that. You know, then you throw in the time differences and the language barriers sometimes that you have to deal with. So it's you know, a lot of times you'll have a question today that you're not going to have an answer to until you come into the office the next morning, or maybe even longer, depending on what the time differences between who you're working with. So it's a lot of unique challenges that we had to start dealing with. At least from my standpoint, I hadn't done that before I started working on the logistics modules. So and over the course of time, as Annette said, you build those relationships. The Italians have been the sustaining engineering partners for the logistics modules ever since they were delivered. So, you know, over that 10 years, you begin to develop good relationships with those people, and it's you know, develop good friendships. And you don't get to see them very often, but still you talk to them on telecons and email quite often. So it's been a very good relationship and partnership between the two, I think.
And then
Richard?
maybe somewhat behind the scenes is I get involved with NASA headquarters in evaluating proposals that coordinate U.S. PIs with the European counterparts. So we get to see what they're doing and evaluate what they're doing and put the right teams together so we can get the best science out of these material science research rack and low gradient furnace or the SQF furnaces. So it's really been nice for me too, because it keeps me abreast of what's going on in the latest in the science and interact with some of the best people in the world in this field. So
That's a good
really
point.
good.
One other thing, what do you guys think was one of your biggest challenges over the past decade working on station, or something that you'd like to share or talk about or reflect on? That
I'll take a stab at least.
Okay.
I'll get it started, I think. Just last year, in fact, we moved from a 3-person crew on board station to a 6-person crew aboard station. And up until that time frame, you know, we'd have 3 crewmen come up, and then and they would stay for a 6-month period of time, and we'd have a flight that we would change out crewmen over that time. And now with 6 people there, what we are experiencing now that we have the Columbus lab there and we have the Japanese experiment module there as well as a U.S. lab, they have unique work environments that all 6 crewmen can also work in now. So it has increased threefold, if you will, the number of hours that are available now for us to be able to perform science operations. Up until that time, and as we culminate the actual architecture of the International Space Station, we have the prime things to be done, of course, is to get the structure developed and built and make sure that all the systems check out and can support. And we are on the cusp now with 6 crewmen there of seeing so much science being realized. And so I think the fact that we went from the 3-person crew to the 6-person crew was a huge step for what the ultimate goal is for ISS.
That's true. Bob, do you have anything to add to that?
Well, in my own particular world, in developing these life support systems, the list of challenges is quite long. You got microgravity you have to deal with, where fluids and gases don't behave the same. You're always challenged with keeping things small and lightweight and power. All that stuff goes without saying, kind of. But it also, I think it's a new experience for us, especially now as, again, in my world, we've kind of transitioned out of development and now in the operation phase, learning what it takes to actually keep complicated systems operating in a challenging environment hundreds of miles away from us, where the people that have the intellectual capital, if you will, and understanding how the systems were designed and stuff, can't go and put their hands on the hardware. They can't touch it. They can't, listen to it. And so you get calls down or you get data coming down that something doesn't seem right, and you really have to stretch yourself as an engineer and work closely with operators and the crew to really understand what's going on and to come up with much more innovative solutions to problems. It's unlike a shuttle program where the shuttle comes down after 2 weeks and you can get into the vehicle and look and say, aha, that's what happened. I know what I need to fix for the next mission. We don't have that luxury now, so we're fixing stuff on the fly. We're having to do it remotely. We're having to interact with the whole operation side. And again, the people that are operating the systems, they're up there supposed to be doing science as well. So we can't be taking a lot of their time to keep the lights on, so to speak. So it's a new environment that we're having to operate in to keep the systems up and running, and it's a great learning experience.
That's a good point. Station is 220 miles above us right now. So does that pose a lot of problems for you all when you're starting to work a problem? You've got to think about this station's not coming down, and I've got to work this problem on the ground. Does that kind of pose problems for you guys?
It's a different kind of challenge. I'm used to doing experiment, going across the hall into the lab and doing it and evaluating it, and now I'm doing my experiment 200 miles away, and I'm not even doing, I'm kind of telling someone what to do, and it goes through this amazing team of technical people and logistic people and this telescience effort, and when you can see what happens, it's really pretty amazing. And in principle, all works very amazingly smooth, and for the most part, things work the way they're supposed to work. But we're up there, so we always see some surprises. For instance, we get the occasional single event upset where some atomic particle comes through and knocks out a solid state component, and you got to stop your experiment and reboot it, and we're not used to doing that down here. And these are things that you're not aware of, and you learn these on the fly, and you deal with them, and the astronauts up there are very helpful, and they want to make sure that they do all they can to get what we need to get done. So it's really interesting.
It's a really good point. Anything from Annette on that one?
I think like Bob and Richard have both said, you know, just working issues that may occur, and I know we've tried to make improvements to our hardware and software on our racks to get more insight, to provide more flexibility and operating from the ground so that we can be more flexible and more supportive of the science in various situations.
Well, thank you guys. Now we're going to move into questions from the audience. So I'm going to ask our local visiting media to please state your name and media affiliation, and please wait for the mic to come to you. And we'll start out right here with...
Hi, I'm Lee Roop with the Huntsville Times. Thanks very much for coming and giving us a chance to talk to you about this. It's fascinating. We've decided as a nation we're going to extend the space station now into 2020, I think. What challenges and what opportunities does that present to you as oh my gosh, it's got to last 5 more, oh boy, it gets to last 5 more years. Anyone like to take that?
I'll start with that one. That was one of the things that we had to consider when we started doing the modifications for the leaving a multi-purpose logistics module up there permanently. In fact, we've changed the name of it to permanent multi-purpose module now. As I mentioned earlier, you know, the first module was delivered in 1998, so that module is 12 plus years old now. And that happens to be the module that we modified to leave on orbit permanently. So we had to start looking at the various components of it, the seals, the O-ring seals to keep the pressurized atmosphere in place, to make sure that they would last the entire time. We were at a little bit of a unique advantage in that we could go replace those seals here on the ground before we launched this time to make that 2020 date. The items that are on orbit right now, obviously you have to look at and say, hey, can we stretch this out to meet that 2020? Will it last that long? Or do we need to have spares in place? Do we need to take some spares up on these last couple of shuttle flights in the logistics module so that we have those spares in place so that we can make that 2020 date?
Okay.
And I'll add one thing to that. From a standpoint of the operations team, I think it's only going to get simpler for us. We hope, we think. As every day that we communicate with our partners, the flight control teams across this world and the remote sites associated with them, we get a little bit sharper with how we conduct our business. So the fact that we know there's a tremendous amount of science that is out there and chomping at the bit to be able to get executed and get into 2020 and enable so much more science to get accomplished, I think our relationships with our partners and how we do business is going to get that much slicker. So our thought process, I believe, is that we will get so much sharper at how we coordinate, how we communicate. It will become even more second nature with every day that we get and every passing year. So it will just continue to be a marvel in a work as the work is in progress.
Yeah, I'm happy to see it continue on. Also, the material science experiments that we do are important, and we learn something from every one of them. But we need to learn more, and to do that we need to vary the processing parameters, and every processing parameter is a new experiment. And if we really want to understand what's going on, we need to do that. We need to do more experiments, and this will give us the opportunity to do that.
Any other questions from the media? Great.
Hi. I'm Paul Huggins with the Decatur Daily. I guess I'm kind of interested in 10 years ago when we were on just getting into this. Has it surpassed? Has it met your expectations at that time? Tell me a little bit about what you were expecting then, and then what you're seeing today, and what your expectations are for the next 10 years.
From my perspective, and I kind of have to force myself to do this every once in a while, but when you're in the middle of a project, your head's down, you're worrying about today's problem and tomorrow's problem and trying to wrap up yesterday's problem. And I really have to admit that I think it was relatively infrequent during the time that I was working on my own project that I stood back and tried to take in the whole picture. But when I do that, it is, you know, quite remarkable, and to just think about how, you know, my project to me seems so complicated and complex and so many problems, and then to look back and to realize that that is going on such a bigger scale, just beyond the sphere of my team, and to see that it's working, it's flying, they're getting through day in and day out, keeping that vehicle operating and getting some great results from it, I think is actually quite remarkable.
And I would agree with that, because you know, 10 plus years ago, you had all of this hardware being defined in parallel, from the big modules to the simple small experiments, and you know, they all had to interface and work together, but yet they were being built basically all over the world. And I think it's been an amazing engineering feat to be built and then assembled and integrated on orbit.
Any other questions from the media? Okay.
It's Lee Roop with the Times again. I like to think about it as, and if I'm wrong, correct me, but you've got all the experiments going on that you're doing on all of the racks, and then you've got all of the things that we're learning about what it's like to live and function in space. And we've done both now for 10 years. Which side of that has been the most, I mean, have we learned the most about living and working in space, or has the science and actually the experiments?
Well, I'm a material scientist, but I think living in space has probably trumped what we've learned in terms of experiments. And it's not that our experiments aren't good, they take a long time to do. And we would like to do more of them. And if we could get more of them done, which hopefully we'll be able to do now that we have a larger crew and more time, then we're going to catch up to living in space.
Yeah, I think once we got past assembly complete, and you know, and not to say that we're still not learning about living and working in space, but I definitely fully expect the pendulum to swing now more towards, you know, the science beating the living and working in space. But I think there'll always be stuff for us to learn.
Yeah.
Next.
Paul Huggins again with the Decatur Daily. Y'all might have heard about the Bigelow ideas for commercial applications for the space stations. How do y'all see that? Is that like a competition, or y'all see that the ISS is just, you really open the door for a lot more opportunities, and we're going to see, you know, far more space stations in just 3, maybe 10 or 15 years from now?
I wouldn't see the Bigelow example or any other of the commercial concepts out there as a competitor by any stretch of the imagination. I think what space station is, it's a you know, the fantastic research complex that only could be done in terms of international governmental cooperation. Given that, though, I think there can be and should be a place for commercial entities, whoever they might be, to begin finding ways to serve other purposes in space, whether it's tourism or some type of other commercial market. I think that's inevitable, and I look forward to seeing what they're able to do.
I agree with that. I think that up to this point, space station has been, you know, a wonderful, a marvelous example of teamwork. And as we move even further, and there's the opportunity for commercialization, for other entities to come and be a part of that partnership, that's what we're going to have. We're just going to open the doors for partnership, and the more diverse the opportunity is, the greater I think the things are that we're going to learn. There's some awesome ideas out there that we don't even have in our imagination, and to open the doors for those things to come in, you know, is only, I think, going to enhance our life here on Earth, and and help us to understand where we are and how we can continue to live on Earth successfully and explore other territory. So I think the more partners there are, the greater the experience is going to be.
Okay. Lee, do you have a final? Okay. With that, this concludes our International Space Station 10th Anniversary Roundtable discussion. I'd like to thank you all for joining us. I'd like to thank our panelists for their interesting insight and history spanning the past decade. If you would, please stay tuned for a video that we're going to air that will show Marshall's contribution to the International Space Station. So thank you for joining us.
CJ, we're about to put the last wire tie on.
This view looking toward the hatch that leads to the shuttle Discovery.